All right, lesson 5, that last class, done all of it in under 10 minutes. So for the first kind of question, we'll have this kind of a graph that's got two x-intercepts and one clear other point. So I guess I'm taking example 1, so it would have been 3 for one intercept, x-intercept, and minus 2 was the other x-intercept, and then we had a clear point which was able to be seen on the handout at minus 1, minus 4. So in this case, what do we do? And I'm not going to bother explaining this all that much. I'm going to show you what to do. What you do is you use the factorized form of y equals a into x minus an alpha into x minus a beta. So y equals a onto what's going to make this 0, okay, I'm explaining just a little bit, is if that and that go in their negative form. So it's going to be, and that looks like a 9, it's supposed to be an A. Still looks like a 9. This and this in their negative form. So x plus 2 into x minus 3. And then we replace the y and the x's with the y and x of our point. So minus 4 equals a onto minus 1 plus 2 onto minus 1 minus 3. So working algebraically through, a is going to be a is going to be 1. Once we have our a of 1, then we've got everything that we need. We've already got a y, and we've already got an x. Now all we need is an a, and we've got it. So we're going to go y equals 1 onto x plus 2 onto x minus 3. And that is the answer. The next general case is when we have a vertex and another point. And this is what we had, something like that is what we had. And so we had the vertex to be, what was it, 3 and minus 4. And we had a point which looked to be just about exactly 2 and minus 2. So in this case, we'll use the vertex form of the quadratic formula, which is, should be a, again, a, x minus h squared plus k. And we know that this is going to be the minus of our vertex horizontal translation, which is the minus of that, and this is the vertical translation. So we plug in those two numbers first of all. Y equals a onto x minus the horizontal translation squared plus the vertical translation, which was minus 4, so I'll go plus minus 4 like that. And we also have our point. So our point can go in as the y and the x. There's our x, and there's our y. So two more numbers to plug in. Here we go. Y then is minus 2. A onto our x is plus 2 squared minus 4. I'll just move these lines out of the way now that you know where everything's coming from. So keep on going algebraically with it. minus 4 plus 4. So we end up with, if I just move this around, A is going to be equal to plus 2. And so we're just about done. Let's just plug in, instead of our A, we'll put a 2. So we go y equals 2 onto general x minus 3 squared minus 4. That is the vertex form of a graph. So now if I'm going to plug that into my calculator, here's how it goes. So y equals 2 onto x minus 3 squared. All squared minus 4. So we'll graph it. And I need more on my y scale, my y minimum, so window. So I'm going to say maybe 8. Graph it. All right, fair enough. So I'll look for the y-intercept. Or no, I'll look for the vertex. So vertex, we're going to go second. Calc, we're looking for the minimum. So minimum, enter, and go through the left bound. So arrow, arrow, arrow. That should do it. Enter. Right bound. Asking for the right bound. So arrow, 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 arrow. That's probably about right. Enter. And now it's asking for the guess. So I'll move it back a little bit. And that looks about right. Just perfect. So enter. And that looks like it can't get much better. So that's the minimum. It would be the maximum if we had an upside down parabola. So let's just do, while we're at it quickly, if we were looking for the x-intercepts. We need a bound on either side there and a bound on either side of there. So we'll do it. So second, calc, and I'm looking for the 0. The intercepts is solving for the equation to be 0. So we go down to 2, which is 0, and we enter. And now I shift up to just to the left boundary from the x-intercept, and that looks like a good left bound. Enter. Shift to the right of it, another good bound. Enter. Shift back, right in the middle, and that's not perfect, but it's not bad. So I'm going to give it a go. I'll guess that. And there you go. That is it. Not a nice x value, but certainly y is 0. And you can do the same thing for the other x-intercept. Now back to, what was it, word problems next? For one of the word problems, I'll pick one of the straightforward ones just to make sure you get the basic case down. So number 4 was a profit versus number of taxis, in this case 1. So here we go. We've got profit and we've got number of taxis. So our formula looks like it needs to get, and this is a good one to do. I'm sure we did this in one of the classes, but maybe not in the other. So check this out. Whenever you get a quadratic equation in a non-standard form like this, get it in a standard form, first of all, is your first step, for sure. So P, profit for the number of taxis, is going to be minus 2n squared plus 120n minus 200. But even that's non-standard, and it'll give you a problem later on if you keep the minus, so get rid of the minus. Multiply each side by minus 1, basically. So we're going to get 2n squared, that's more standard, minus 120n plus 200. That's standard. That's much better to work with. So what is it asking? Just keep in mind this is the profit side, and this is the number of taxis side. So it was asking us for the number of taxis. Yes, that's the A question. Is how many taxis for the maximum profit? So do our minus B over 2A. Now that we have our B's and A's in the right place, so minus 120 is B 2 times 2. So we end up with positive 120 over 4 gives us 30. So 30 taxis is for the optimal profit. It's probably going to ask us what that profit is, and it does. That's B. So let's go back to the original formula, P for 30. So what do we got? 36 two zeros minus 200 minus 90 times 1800. So 1600. And we didn't do any of the C's. I better do a C question. What's C say? How much money is lost per hour if no taxis are on the road? Well, if no taxis are on the road, then the number is 0. So 120 times 0 minus 200, which is the answer, minus 2 times 0 squared. So basically it's the 200. How much money is lost? $200 is lost, minus $200. That's it. Quickly, but that's it.